And in the last video, I would like to discuss two coefficients, which is coefficient of correlation denoted by R and coefficient of determination. So coefficient of correlation is a measure of the strength of the linear relationship between two variables y and x, and it is estimated using this expression over here. What you need to remember is that the coefficient of correlation lies between -1 and +1. So it cannot be lower than -1 and it cannot be higher than +1. As a rule of thumb, you can use this table to interpret the correlation between the two variables. So if the correlation coefficient is 0, then we say that there is no correlation. If it lies from 0 to positive 0.3 or from 0 to negative 0.3, we say that there is very low positive or negative correlation. If the correlation coefficient lies between positive 0.3 and positive 0.5 or negative 0.3 and negative 0.5, we say that there is low positive or low negative correlation. If it lies between positive 0.5 and positive 0.7 or negative 0.5 and negative 0.7, we say that there is moderate positive or negative correlation. We can also make a conclusion about whether we have higher positive negative correlation, and this will be when we have the correlation coefficient line between 0.7 and 0.9 or negative 0.7 negative 0.9, and if it lies between 0.9 and 1 or negative 0.9 and 1, we say that we have very high positive or negative correlation. So if we go back to our example about the reaction to a certain drug, the correlation coefficient is estimated to be 0.904, and since it lies within the interval of 0.9 and 1, we say that there is very high positive correlation. Another coefficient is the coefficient of determination, and it is a measure that represents the proportion of the total sample variability around the sample mean y that is explained by the linear relationship between y and x. Here is the formula, how it is calculated, and you should remember that this measure all lies between 0 and 1, so it cannot be lower than 0 and it cannot be higher than 1. And the practical interpretation of this coefficient of determination is that at some percentage that is estimated by this coefficient of determination of the sample variation in the dependent variable can be explained by the estimated linear regression model. Let's go back to our example of the reaction to a certain drug. The coefficient of determination for our example would be equal to 0.817. So the interpretation will be the following: 82% of variation in reaction time, so 82% of variation in y, can be explained by using the percent of drug in a straight line model. Or in other words, we can say that 82% of variation in our dependent variable is explained by the estimated model.